Hi everybody, Mitch here. This is another quick tutorial video. I want to show you the basic structure in the Unreal Engine project of my Sonic Lifeforms app. So let's jump right in and see what we find there. Okay, we're here in the Unreal Engine project of the Sonic Lifeforms album. Let's quickly jump in. It starts with the album cover, and after that there's a random track being picked and it starts with that. And the central control element and also the central visual element here is the big XY pad with the moving cursor here. And you see, if you keep dragging the cursor, there's a little grid with some information fading in, and that gives you the information about what you can actually do with the cursor. So you've got two axes here, the x-axis and the y-axis. And the x-axis is responsible for the intensity of the rhythmic elements of the arrangement, and the y-axis here is responsible for the intensity of the atmospheric elements. And you can of course choose any position in between. So if you go to the upper left corner, it's going to be very minimalistic because the probability for the rhythmic elements as well as the atmospheric elements will be relatively low, and so only a few elements will be audible, and still it's procedural, so it's going to keep evolving. And there are some other parameters that are constantly changed, like effect settings, filter settings, stuff like that. And for instance, if you move the cursor to the lower right corner, then you will have a pretty intense arrangement because the X value is high, the Y value is high, so both the rhythmic and the atmospheric elements are will have pretty high probabilities to be, of being played. Okay. So this is the basic principle. So let's see how this is done in this project. Okay, so the core element is still what I like to call the SLF system, which is a combination of a blueprint that is controlling the randomizer and the randomizer weightings and the duration of the randomizer cycles for each layer, setting the audio assets that you are using for this procedural music system. It can host up to 8 layers of music. It used to be 4, but I extended it to 8 layers. And as I said, it's the combination of this master blueprint here, and this master blueprint is spawning an instance of this MetaSound source here. I've discussed the structure of the MetaSound source in the other video, so I'm not going through that in detail here. You see it has grown to 8 layers, it used to be 4 layers, but the basic principles stayed the same. So if you want to know how this is made up in detail, please watch the other video. This master blueprint here is the controlling element for the procedural music system, but you can run more than one instance of it at the same time, so it's no problem. So when you are using that blueprint, there is a variable where you can set if it's actually really the master, or you can also set it as an extender. It's the same blueprint, but some logic is being switched internally so that the BPM value of the master is transferred to the extender module, and also the quartz clock is referenced from the master blueprint, stuff like that. So it's no problem to extend this system. So if 8 layers of music is not enough, then you can spawn another one, and then you have 8 more layers, and so on and so on. So you can extend that as far as you like to. And in my particular case, I'm always using 2 instances of these SLF systems at the same time, because we've got 2 axes here, one x-axis and one y-axis. And I'm using the x-axis for the main musical elements of the arrangement, like the drums and all the rhythmic elements, the bass, the drums, maybe the basic chords. So all the core elements of this arrangement, of this track, will be on the x-axis, and the y-axis is there for you the more atmospheric parts that give depth to the arrangement, maybe some additional melodies, sound effects, stuff like that. So I've got 8 tracks for the x-axis and another 8 tracks for the y-axis, and this is how the basic system works. So always 2 instances of these SLF systems running in sync, and for that to work, of course, I need a master blueprint that controls everything, which is this blueprint here, my XY path blueprint, and this was the only blueprint that is present in the project from the very beginning, and all the other blueprints and all the other widgets and MetaSound sources are being spawned from here. So this is the central element, my main blueprint here. When you take a look at the details panel of this master blueprint here, you see that there is one big array here with 8 elements, and these 8 elements correspond to the 8 tracks of the album. So each album track has an array element, and each array element itself is a big struct. So a collection of variables here, and let's quickly go through them. Of course, we've got the track name for the album track. Then we've got the BPM value here. So I'm setting the BPM value and transferring them to the SLF systems that are spawned by this track here. And here are the references to my 2 SLF systems. One is I'm calling the master, and the other one I'm calling the extender. But I could also have called them X and Y, because that's what they actually are. One is responsible for the music that's being controlled by the X-axis, and one is for the Y-axis. And these SLF systems that I'm referencing here are actually child blueprints of my SLF master blueprint. So what I'm doing is I'm creating a child blueprint from the master, and I've got, for each track of the album, I've got 2 of those child blueprints. So if we look at this jazzy track that we have been listening to at the beginning, I've got the master blueprint. This is the one that's responsible for the X-axis, and I've got the extender blueprint, which is for the Y-axis. And we take a quick look at the variables here, the default settings for the master. For the X-axis, you see that most importantly, we are setting which musical content we are using for each layer. For layer 1, it's the main drums. Layer 2 is the bass, then some chords, and so on and so on. I'm not even using all of the 8 layers here, but for other tracks, I'm using all of the 8 layers, but not for this one here. And all the other default values. So this is my possibility here to mix these together in terms of volumes. So this is the basic settings for the volumes, then the delay sense, effect sense, not many of them are used here. Then of course I've got a low cut filter here per layer. So like for instance, layer 1 hosts the main drums, and I've got the low cut filter enabled, and this is the duration of the modulation cycle. So pretty long, 47 bars is the duration for one complete cycle of modulation for the low cut filter here. The master filter is not enabled by default, but it can be remotely controlled, so that doesn't mean that the master filter will never be enabled for this track, but not as a default value here. And then the next things we already took a look at in the previous video, but let's quickly recap. So we've got the levels, fade in times and fade out times. So if a certain element is faded out, then these values tell the MetaSound how long the fade out should be. The same for fade in times. So that makes a big difference how the whole arrangement sounds. Is it something that one element flows into the other, or are they quick transitions? So this is very important if you fine tune how the music system should sound. Then also very important that the randomizer duration times per layer. So for instance, the main drums here, I've got a duration time of 24 bars, which means every 24 bars the randomizer rolls the dice, and then there's a new decision if the drums are faded in or out or kept alive depending on the previous state. So if they're already being played and the randomizer says, okay, let's give it another 24 bars, then nothing happens, they just continue playing. But if the randomizer says, okay, they are to be turned off, then according to the fade out time, an envelope will fade them out, and then they are gone from the arrangement. And 24 bars later, the randomizer will roll the dice again, and a new decision is being made here. And these are the default values for the probabilities, for the randomizer weightings. These all of these parameters will be overwritten from the master blueprint, from the big controller blueprint later on, but these are the initial values. And if you see, I used here a value that's really close to 0, but I didn't actually use 0 because I've got a logic in there that checks if the layer chance is set to 0, and then it would really just turn off the layer to save CPU. And as I know that this value is going to be overwritten later on, I didn't want it to really turn off, so I set it to something just a little bit above 0. And actually what I can read out of these settings is when you're starting out on a track and the X value is 0 at the beginning, then it's most likely for one of those two elements, which are some keyboard chords, to be played. And it's even more likely for the content of layer 4 to be played than layer 3. Again, that is combined with the other sonic lifeform system that is there for the y-axis, and so there's enough variation that if you add the filter movements and the effect movements and all that stuff, it's still never the same. Some basic settings here, but most of them are being overruled later on from the master blueprint. So this is how I do the basic setup for my SLF systems. The same thing here, the extender version, which is the one that is responsible for the y-axis, and you see here you've got some other musical elements, but all the other settings we know already from the previous preset here. All right, so let's hop back to the master blueprint here, the one that controls everything. Okay, where did we stop? Here, the references for the master and the extender. These are the two blueprint presets that we have been looking at right now. And then, this is interesting, I'm setting again probabilities here for the extreme settings for the x-axis and the y-axis. So I'm setting all the values that I want to have when the cursor is being moved on the x-axis to the very left. This is what happens here. And the same thing when the cursor is being moved to the right side here. So the x-axis alpha 0 values are for the left part, and for the right part here the alpha 1 settings. And everything in between, if I'm setting the cursor on the x-axis somewhere in the middle, those two values are being lerped, and then we've got a resulting value, and that is fed to the randomizers. And the same thing is happening for the extender SLF system for the y-axis. So I'm setting the alpha 0 values and the alpha 1 values, and this gives me the opportunity to really fine-tune this particular album track. And all the other stuff is more for the visual elements. So like a background image for every track that is being used for the menu, for the track selection. Then cursor primary and secondary colors. I've made that as a variable, although it's the same for all tracks, because at the beginning I had this idea that every track has another combination of colors for the cursor, but it turned out that it was just a bit too intense, and so I left the same coloring for all tracks, but I could change it here if I wanted to. The same thing here, background material is actually the material instance I'm using for the visuals. So I made a master material that gives me the basic functionality for the visuals, and then with material instances with a lot of parameters that are accessible there, I can adapt this material to completely different visuals for every track. So this is another topic, but I'm not covering anything that goes into the domain of materials, because I'm really not an expert for materials, which was just more like trial and error, and I'm happy that I came up with something that looks all right, but I'm by no means an expert for that, so I'm not talking about that. Exactly the same struct is there for each and every track. So I've got 8 tracks from 0 to 7, and they all have the same setup here. So this is the most important part of the master blueprint that I can access from here. And maybe we take a really quick look at the blueprint here. This is the master blueprint that controls everything. Really just a quick overview. I'm not going into detail, that would be not possible in a video here, but just to give you a quick overview. So when you start it, I'm resetting the submix output volume just in case. After that, I'm quickly showing the album cover here. After that, I'm reading data from the save game, because I don't want the app to always start at default values. I want the app to remember the last user settings, and this is the readout for that here. And also if it reads out if the user has chosen to see the welcome screen or not. stuff like that. So this is just reading out of the save game. Then here I'm choosing a random start track. Pretty straightforward. Set that randomly chosen start track as the current track. I'm resetting the track selection array because I've got an option for automatic track selection after a certain period of time. So like every 5 or 6 minutes, there will be an automatic transition to a new track. And to avoid repeating the same track before all other tracks have been played, I'm writing that into an array, and this is initialized here with this function here. Then next up is I'm disabling the screensaver for mobile devices, because that would be quite annoying if you want to move the cursor and after like 30 seconds the display is always going to screensaver mode, or shutting down the whole display. And this is just preparation. I'm setting up my my materials for the XY pad, and reading out all the information that is needed for dynamic material instance. And this is done from the info that is written to the struct that I've been showing you. And so this is the array, and we know which track index we have here as the first track. And I'm reading out some information about the track name, and of course some information for the material instance here, and I'm creating that, and then I'm spawning the XY pad widget so that we can see something. And then next thing is the really interesting stuff. Here we are spawning the first 2 SLF systems. So according to the track number that the randomizer has chosen as the starting track, I'm reading out all the important information from the struct, and by this reference I'm spawning the SLF blueprint master for the x-axis, the same here for the y-axis, and then transferring the most important information to the SLF master here, and the SLF master itself will transfer this information to the MetaSound source. The same thing for the extender blueprint here for the y-axis. So this is just spawning the first 2 SLF systems. Then we're subscribing to mouse capture end, which means we have been already spawning the widget for the XY pad, and there it recognizes, of course, when I'm touching the XY pad with my finger and when I'm releasing that, and we are subscribing to the moment that the XY pad is being released. And this immediately triggers new randomizer weightings for my SLF systems. So we're reading out all the alpha 0 and alpha 1 values for the x-axis, the same for the y-axis. lerp nodes will morph between those values and set them and send them over to the corresponding blueprints that are controlling the MetaSounds. So this is happening here every time I'm letting go of the XY touchpad. All right. And after that, I've got a little system here that's controlling the master filters of the 2 SLF systems here. So I have to quickly jump into the app again and show something. When you're closer to alpha 0 on the x and the y axis, there will also be a filter movement. So at the upper left corner, both of the SLF systems will be filtered down with a low cut filter. So not completely, but it's gonna be a little bit duller. And if you are moving like to the other direction here, the filters are slowly opening up until they're completely open. You see the filters are morphing, and now they're like on 800 hertz or something. So you're still hearing everything, but it's filtered down. So that adds to the impression that we're here on the upper left corner. We're minimalistic. And here we are in kind of an intense version of the arrangement. And to make that happen, I've got this little logic here because I don't want the filter to jump from one position to another. That wouldn't sound very nice. So I'm using some timeline nodes here and some logic that the filter is actually moving there. And it's recognizing if there's already a movement taking place and stuff like that. So this is controlled by this section here. And this is for new track selection, either manually or by the auto track system. So we're getting the information from actually the XY widget, and then we're subscribing to that. And when I'm not the XY widget, the menu widget. So if I'm selecting a new track from the menu widget, then I get the events here, and then some logic is taking place to really make a smooth transition from one track to the other. There are some things to keep in mind. When track transition is happening, it doesn't make any sense to change the XY position of the cursor, and so the XY pad is being disabled. The whole screen has this little blurry effect so that visual transition is looking nice, and then after the transition has finished, the blur goes away, you get back the control over the XY pad. This is all happening here, or this is triggering functions where I make that happen. This is a function for what's happening for the track changing, and then I've got two functions, what's happening when actually the music of the old music system has really been faded out, and the same for the Y system, and the old blueprints are being killed, not so that they are not using any CPU power, and the new blueprints are in charge, references are redirected and stuff like that. This is what happens here. And the same is true for random track selection. So if I've got this auto track transition feature in place, this is happening here. Just some little helpers here to remove the blur after the track transitions. And this is my array that is counting which track has already been played and which tracks are available for the randomizer until all the tracks have been played once, and then it's being reset. Then next thing is, of course, if we're working with quartz clock, we have the possibility to subscribe to quantization events, and this is what's happening here. I've subscribed to quarter nodes here. So every quarter note of the currently running music will be reflected here. Every quarter note there's a new event coming out, and I'm using that, for instance, for my pulsing logo here. Show you that. Okay. So if a track is playing, you actually got the logo pulsing here exactly in sync to the BPM. It looks a little bit nicer on the iPhone screen. It's scaled down here. This is controlled here, subscribed to quarter notes, and then with little timelines make the two elements of the logo pulse here. And another thing is that I'm modulating the cursor size so that it just looks like a little organic cursor, not so static, stuff like that. Here I've got a timer for showing track info and credits every now and then. I'm randomly adding some very soft but effective reverb here on the whole submix for the X and for the Y elements. So that gives me some more complexity or some more variation. What do we have here? The sleep timer is also a different section here. You can trigger that from the menu widget. There's a button for triggering and setting up the sleep timer, and the whole logic for the sleep timer is here: start sleep timer, stop sleep timer, a timeline controlling everything, controlling this the screensaver, because at the end of the sleep timer, of course, the phone should go to sleep, so that needs to be turned on again. And of course, the main function of this sleep timer is slowly fading out over time. So if you set the sleep timer like for 20 minutes, then over 20 minutes there should be a slow fade so that at the end of the sleep timer the music is completely turned off. So that's what's happening here. So this is just a quick overview to show you what the main controller Blueprint does. And yeah, I think I'll wrap this up. Just really wanted to give you an overview over the structure of this whole project, and I hope I could give you some insight on that. And see you next time. Thanks for listening. Bye bye.